All right, so record's on, and I'm going to share over. All right, so y'all should be seeing my pad now. Oh, I need this thing to hide. All right. And over there. All right, let me get one more in here. Robert Skaggs. All right, y'all, so these notes are going to start in 2.2, and it deals with functions. So the first thing we're going to do, we're going to go over a few definitions. So some things you might need to refresh are on your domain. So remember, in a function, your domain is the set of all x values. And it's also called the independent variable. And what that means is I can pick any x's to put into the function, okay? Now your range, our range is going to be the set of all the y values. And we often call that the dependent variable. Because y values depend on what x values we put into the function. So if you're looking at a function such as your pay, your hours you worked would be your domain, and your pay would be the range. So if you notice, you can work any hours you want, but your pay depends on how many hours you work, okay? All right, let me get Aiden in here real quick. Oh, that's right there. All righty, so a correspondence, they use that word in here. You know, a correspondence just shows a relationship between the range, or how about the domain, and the range. Okay, so a lot of times they use a little table. They'll put the domain on one side and the range. They might show it as a set of ordered pairs. Okay. Now, the one we're worried about the most is a function. So a function is a correspondence in which each member of the domain has one and only one range value. So what that means is if I had an x value of 5, I could only have one y value come out of the function. I couldn't get two different y values for one x value, okay? So what I'm going to do is show you some of the examples like you'll see on the homework. So this first question just wants to know, we're going to determine if the correspondence is a function. Okay, so let's try this first one here. They're giving me a domain in the first column and a range in the second column. So my domain has numbers 9, 24, and 10. The range has 25 and 7. So the 9 points to the 25, 24 points to the 7, and the 10 points to the 25. So the question is this a function? So what we got to do is take each of these domain values and make sure they only point to one range value. So notice 9, it only points to 25, so that's good. 24 only points to the 7, so that's good. And then the 10 only points to the 25, so that is good. So all my domain values only go to one range value, so this is definitely a yes. Any questions on that? All right, y'all, so number 2, the same type thing. I got a domain in the first column and a range in the second. All right, so this time I got a -5, 4, and 7. I've only got one range value of 5. All 3 of these in the domain point to the 5. So my question would be, is that a function? And this is definitely yes, because each of my domains only points to one range value. Okay, so then let's go to the next one. All right, y'all, this one has 64, 27, and 125. The range is a -4, -3, -2. Each one of these points straight across. So this one would definitely be a function because each one of my domains is pointing to only one range value. So once again, we have a yes. So now y'all are probably wanting to see a no. So here we go. I got a domain. Now this time the domain is going to be cities. So I got Detroit and Boston. My range is actually going to be teams. So like sporting teams. So over here I got Lions, Tigers, Pistons, Celtics, Bruins, and Red Sox. So Detroit points to the Lions, the Tigers, and the Pistons. Boston points to the Celtics, the Bruins, and the Red Sox. So is this a function? This time we got to say no because each of my domains is pointing to 3 different range values. And remember, a function, the domain can only point to one range value. So since they're each pointing to 3, this is definitely a no. Okay, so just remember, to be a function, and we'll do things later on when we look at graphs to determine functions also, but for now, each x value or domain can only have one range value or y, okay? All right, so now we're going to look at what we call function notation. And this is the what y'all might call the f of x. Okay, so the f of x is just symbolism. This just tells me we got a function. And then that x there, it just tells me the variable. So if my variable was the a, this would be f of a. Now, a lot of times functions don't always use the f. Like in physics, if you do physics later and they give you formulas for acceleration, they might put an a of t instead of an f of x because they're dealing with time in theirs, okay? Now, the thing about this, if there's a number in place of the x, so if a number is in place of the x, then that number is used to replace all the x's. In the expression. Okay, so it just tells me what I'm going to replace all the x's with, and then I evaluate it and get my answers. All right, so for these examples, and this will show you a lot more about that function notation.
Can you actually go back?
Uh-huh. Okay, and then the question?
I was just trying to write it down.
Okay.
Going too fast.
Okay, I probably pulled it too quick, yeah. I'll try to hold on when I do my paper changing.
Thank you.
I'm used to being on the big whiteboards, you know, and y'all can write them all day long. All right, y'all, so this one says, given h of x equals x plus 17, we're going to find each of the following. Now, the thing you got to realize, this h of x, we don't do nothing with it. It's just going to tell me that x is my variable in this expression. All we do is put whatever number they give us in for the x, add that to 17, and get these answers, okay? So the first one they want us to find, h of 0. So h of 0, since they're telling me x is a 0 now, we're going to replace this x with a 0, and that's going to give us a 0 plus 17. And 0 plus 17 would give me 17. Okay? Then they want us to find h of a negative 1. So what we're going to do, put a negative 1 in for the x, so we get a negative 1 plus 17. Now this is where I get a few of y'all on your signs. Remember, if you got unlike signs and you're adding, subtract the numbers and get the sign of the larger number. So 17 minus 1 would be 16, and since the larger number is positive, that stays positive. All right, y'all, how about a h of a negative 2? Same thing, we're going to put a negative 2 in for the x, so we get a negative 2 plus 17. And those are unlike signs again, so 17 minus 2 is 15. Larger number's positive, so that stays positive. All right, then they broke out a h of a positive 2. Same thing, put a 2 in for the x, so 2 plus 17. And that's what, 2 plus 17 will give us a 19. So see, this is pretty much shorthand. Instead of me saying, hey, put a 0 in for the x and tell me what you get, I can just say, hey, find h of 0. Okay, so it's almost like shorthand. Now, the last one of those is a h of a c plus 5. So since c plus 5 is where my variable is, I got to replace that x with c plus 5. So I'll have c plus 5 plus my 17. So you still got an x plus 17, although our x is now 2 parts, okay? Now, only thing I can do to this is add the like terms. So the c has no more c's, so bring it down. The like terms would be the 5 and the 17. Add those together, and I think we get, what, 22? So that final answer would be c plus 22. So they're going to hit you with variables on some of these, and just remember, you cannot add those variables to those numbers. All right, let me see. That's pretty easy, so I'm going to do this one. They're given f of x equals absolute value of x plus 4. We're going to find each of the following. So where a is going to be f of 1. So what we would do is put a 1 inside for the x, so that's going to become an absolute value of 1 plus 4. So once you get everything substituted in, you still want it to look like the function. So on this problem, treat inside the absolute value like you would parentheses. It's got to be the first thing I do. So absolute value 1 is 1, and then bring down your plus 4. Now we just add, and 1 plus 4 give us 5. Oh, let's see what we got here. The next one is f of 4. So I'm going to put a 4 inside those absolute values, and then at the end I still got a plus 4. So once again, the first thing we got to do is the absolute value of 4, and the absolute value of 4 is 4, and then we still got a plus 4. Now, remember, if you weak on your absolute values, if you hit second 0, it brings up a list. Absolute value is the very first thing. Put your 4 in there and hit enter, and it'll give you a 4. Now, y'all, I think the other way to get absolute value is if you hit the math button and go over to number. It's the first thing you see in that list, absolute value. So either way, it'll give you a 4, okay? And then that 4 plus the 4 will give us 8. Now, y'all, I'm going to sort of, I'll show y'all a trick in just a second on these. This one wants f of a minus 4. So inside the absolute value, we're going to put a minus 4, and then outside is a plus 4. So what's going to happen on this one, since we don't know the sign of this a, this one technically cannot go no further, so you got to stop here. So stop here on this one. Okay? And that's just because we don't know the sign of the a, so if you brought it out, it could be a positive value or a negative value, so we're not able to go any further on this one. So I sort of didn't like that question, but when you get to that one, just put it in after you substitute it, put in that answer and be done with it, okay? All right, given f of x equals x to the third, we're going to find each. Now, I'm going to show you something that'll work with all the ones I use numbers on, but we can't do this on the ones that give you variables for replacements. But watch this. I'm going to go to y equals, I'm going to clear this out, and I'm going to put in the x to the third. So x, and then use that carry it over here and put in my 3. Now remember, older calculators, you might get the arrow with a parenthesis. Just put the 3 in parentheses and shut that. Watch that. The first one I'm going to find is f of 0. That's going to equal 0 to the 3rd power, which is 0. But y'all watch this. I'm going to go to the table by hitting second graph. And let me find the x value is 0 and look at that y value. It is 0. Next, let's find f of a -1. So watch this. On here, f of -1 shows me it's -1. So let's see if it's right. -1 to the 3rd is -1 times -1, which is 1, times -1, which gives us a -1. Next, I got f of -3. Well, watch this. -3 on here is showing me a -27 there. So let's see if that's right. We got -3 to the 3rd power. Now remember, negative numbers, always put them in parentheses if you're using the calculator to find them, okay? So let's see, -3 times -3 is 9. 9 times -3 is -27. So that table's giving me everything I need on my answers, right? F of f of 3, so this one's a +3, which will be 3 to the 3rd power. So let's see, over here, if I go down to 3, I see that I'm going to get a 27, because 3 times 3 is 9. 9 times 3 is 27. F of 10 is going to equal 10 to the 3rd power. And I can go over here and go down to 10. And woo, look at that. 10 times 10 is 100, times 10 is 1,000. Now, the only one I can't use that on is this one that has f of a -5a. That's going to equal -5a to the 3rd power. When you got stuff inside parentheses raised to exponent, this exponent affects both of those. So this was like -5 to the 3rd power, or -5 to the 3rd power. -5 times -5 is 25. 25 times -5 is a -125. And then what I do on variables, since the a don't have an exponent behind it, I would treat it like a 1. And on variables, you multiply the exponents. So that would be a. 1 times 3 is 3. Okay, so you got to cube the a and cube the number on that one, okay? All right, so I'm going to let y'all write that. Any questions on those? Y'all doing pretty good on them, huh? Y'all are too quiet for my class, okay? I'm going to toughen it up on y'all. Oh, so let me tell y'all, if y'all got to slow me down, don't use chat, just unmute and tell me, hey, what are you doing there, okay?
Yes. Can you go back to, I was trying to mute
the Actually, if y'all want to
go back out.
Let me I'm going
to trying to write down the last part.
I'm actually going to Yeah, so I got it to where y'all can actually unmute yourselves. Okay. So you notice this sort of goes back over some exponent rules in some of these examples we're going to do. All righty, so y'all good?
Yes, I'm good. Thank you.
So now, let's see if y'all remember what this function is. I got a function f of c equals 9/5 c plus 32. Y'all ever seen that formula? So let me tell y'all what this is then. This finds the Fahrenheit temperature when you know the Celsius temperature. So what they want us to do, we want to find the Fahrenheit temperature corresponding, oh, let me let one in real quick, corresponding to the temperature of a -5 degrees Celsius. So basically what they want me to do is find f of a -5. So we replace the c with our -5. So that'll give me a 9/5 times -5 plus 32. And I was happy they gave me a 5 on this because it's going to cancel with that denominator when I multiply. So if you want to treat it like a fraction, put a 1 under that -5. But remember, anything on top can cancel with anything on the bottom. So this -5 and 5 cancel each other, making a -1. So I basically just divided -5 by 5, made that a -1. So that now I got 9 times -1, which is a -9 plus 32. Now, calculator, let me click that screen. All you got to do is 9 divided by 5. And then that's going to multiply by -5. And I get a -9. So either way, y'all, the calculator will do them or do them on your hand like I just did. All right, now, unlike signs again, so 32 minus 9 is 23. Larger sign's positive, so this is positive 23. And you can do those on here, -9 plus 32, and you get a positive 23. So let me show y'all this in Celsius. This is pretty cool because in Celsius, water boils at 100 degrees. So do y'all know what water boils in Fahrenheit? Because if not, you're about to. So watch this. The 100 divided by the 5, 100 divided by 5 makes that a 20. 9 times 20 is 180 plus 32. And y'all, 180 plus 32 is 212 degrees Fahrenheit. Y'all knew that though, right? And y'all can do that with, in Celsius, things freeze at 0. But if you put a 0 here, that would cancel, and 0 plus 32 would give me 32, which is what water freezes in Fahrenheit. So some of y'all are going to get to play with this kind of stuff in your science classes. Probably physical science and chemistry, maybe. All right, so now they want us to graph the function. They're giving me f of x equals -2x plus 2. Now, y'all, this one, they're giving you a little table of x and y, okay? They're giving me a -2, a 0, and a +2. They're not giving us the y values. So what they want us to do is put all these x's into the function get the y values, and then once we got the y values, we're going to graph it, okay? So let's see, first I'll put a -2 in for the x. So f of -2 will equal -2 times -2 plus 2. So follow your PEMDAS, parentheses, then exponents, multiply and divide left to right, add and subtract left to right. So the first thing I got to do is multiply. So -2 times -2 would give me a 4 plus my 2, and then 4 plus 2 would be 6. So when x is -2, y will be 6. Then I got f of 0, so I'll have -2 times 0 plus 2. So once again, we're going to multiply first. -2 times 0 is 0, plus my 2, which gives me 2. But remember, we knew that from yesterday. If we put zeros in for the x's, the answer is going to be that number at the end every time, okay? And then finally, let's put a 2 in. So f of 2 equals -2 times 2 plus 2. So you always want it to look like your function, okay? Except for that x is now a number. All right, so let's go. -2 times 2 is -4 plus 2. Unlike signs, so subtract. 4 minus 2 is 2. Larger number is negative, so that answer is negative. So when x is a -2, I got a -2 for my y. Okay. Now, let me go to MATLAB and graph this one, because some of y'all might not have been here yesterday, and I want y'all to see how to graph this. So I'm going to go to a new share to the MATLAB. And this is 2.2. All right, it'll get here in a second, I think. And I'm doing number 10, so let me click to number 10. And I'm hoping it's leaving the problem the same as I just did, y'all. Oh, let me do that again, number 10. So that was like the first ones we were doing. So let me see, I got a -4. Ah, they changed it. Okay, so I'm going to rework it using their numbers. So let me write this down. F of x equals -4x plus 4. All right, so we'll work this one out, and then I'll come back and show y'all how to actually graph it. Oh, dang it. I didn't get them x values. Let me go back. All right, x values are -2, 0, and a +2. So it looks like it's using the same numbers, right? So here we go. All right, so y'all should be seeing my pad now. So I'm going to do this 3 times, get these numbers, and then we'll go back and graph them. So first, we're going to find f of -2. So that's going to be -4 times -2 plus 4. All right, so we're going to multiply first. -4, -2, give me an 8 plus 4, which will give us 12. So f of -2 gives me a 12. F of 0, we know what that's going to do, right? -4 times 0 plus 4. Once again, that's going to give me a 0 plus 4, which is 4. So you're seeing every time I do zeros, I'm getting that last number. And then finally, we got what? An f of 2. That'll equal -4 times 2 plus 4. So unlike signs, that's going to be what? A -8 plus 4. So unlike signs, 8 minus 4 is 4. Larger number is negative, so that'll be negative. So at 2, I get a negative 4. All right, y'all, I got my 3 points. So let me go back to the homework page. Now, we got to put in our answers first. So f of negative 2, I got a 12. F of 0, I got a 4. And then let's see, f of 2, I got a negative 4. So you would put in your points first and check your answer. And it's going to say, okay. So then we go to graphing it. Now, click enlarge graph. This is going to be a straight line because it's just got an X in it. So we click the straight line tool. Now, you can only plot 2 of the points. All 3 of the points will be on the line, but you can only plot 2 of these points. So I'm going to plot negative 2, 12. So I'm going to go over to negative 2 and up to 12. And remember, it shows my point up in that little yellow strip on top. So click that. And then my next point I'll do 0, 4. So there's 0, go up to 4. It's showing me at 0, 4. Now, 2, negative 4 is on the line. So you're sort of checking your accuracy with that 3rd point, but I didn't need it when I graphed it, okay? So I would just save that and then check my answer. All right, so let me write this next one they're giving me on this math lab, and then we'll work that one. So this one has f of x equals negative 7 plus absolute value of x. Ooh, the x's and y's, let's see. Looks like they're giving me 5 numbers, negative 2, negative 1, 0, 1, and 2. Now remember, if you wanted to get these numbers quick, you could go to y equals, clear that out, and put this negative 7 plus absolute value, which is math, arrow over, enter, and then put your x in there. Or you could use second 0, remember. But if you go to second graph, which is our table, it's got all my numbers here. Let me start at negative 2 up here. So at negative 2, I should get a negative 5, and then a negative 6, and so on. So let's do them by hand. F of negative 2 will equal negative 7.
Add.
Am I on the wrong? Oh, let me go back, right? I'm on the other page still.
Yeah.
I'll get better at this one day, y'all. All right, so now we're on a good page, right? So I did negative 7 plus, I put that negative 2 into that absolute value. Yeah, I'm not used to switching back and forth as much, you know. Because in school, I can help y'all do all that in that little lab, you know. So now, first thing you got to do is absolute value of negative 2. So the absolute value of negative 2 is a positive 2. Remember, absolute value will always come out positive. And then negative 7 plus 2, 7 minus 2 is 5. Larger number is negative. So there's that negative 5 we got. Next, we got an f of negative 1, which will equal negative 7 plus absolute value of negative 1. So that's going to be negative 7. Absolute value of negative 1 is a positive 1. And then, y'all, here we go. Negative 7 and 1. 7 minus 1 is 6. Larger number is negative, so that stays negative. All right, absolute value on this one. Whoops, that's a 0. So f of 0 will be negative 7 plus absolute value of 0. So bring down that negative 7. Absolute value of 0 is 0. And then negative 7 plus 0 is negative 7. So it looks like I'm following right along with that calculator. Now let's put in a 1. So f of 1 will equal -7 plus absolute value of 1. That's going to be -7 plus. All right, so the absolute value of 1 is 1. And then -7 plus 1 will give us a -6. But if you remember yesterday when we did the absolute value, they're symmetric. And if you notice, it looks like -7 is 0, -7 is going to be my vertex point on it. And then it starts getting symmetric, okay? Last one is a f of 2. That'll be -7 plus absolute value of 2. So that's going to be -7 plus a 2. And y'all, -7 plus 2 will be -5. So, absolute value, when you do the math lab, you got to choose the tool that looks like a V. So let me go to the math lab. All right, so y'all should see the math lab now. So what we're going to do is put in these numbers we just got. So at -2, I had a -5. At -1, I had what, a -6. Then I had a -7. Then I had a -6. And then I had a -5. So you're going to put your points in again and check that answer. And then remember, it's going to want me to graph this. So I'm going to click graph. Now watch over here. If you notice, when you click on these, that one says it's a line tool. This one says it's an absolute value tool. So click it. Now remember, the first point you got to plot is the center point, which is this 0, -7. So we're going to go to 0 and then down to what, -7, and hit enter. Now, an absolute value, you just got to plot one more point and it'll finish the graph up for us. So I'm going to do that -2, -5. So here's -2. I'm going to go down to -5 and click it. But every other point in that graph will be on here, because here's -1, -6, 1, -6, 2, -5. All points will be on here, okay? Save that and check that answer. All right, so let's try this one because it's got a couple X's on it, and then we'll move on to another topic on here. So I'm going to write this down real quick. F of X is going to equal X squared minus 4X minus 8. The X's they give us are 0, 1, 2, 3, and 4. All right, so I'm going to switch back and let us work this. And then we'll go graph it, okay? Now remember, these are X squared graphs. So when you graph this in MATLAB, you got to use the parabola tool. And the first point we got to plot is going to be that center point again, okay? So we're going to have to find out where our center is. So first, let's put a 0 in. So f of 0 is going to equal 0 squared minus 4 times 0 minus 8. So we had two x's in this equation. We got to put 0 in for both of those x's. All right, exponents have priority. 0 squared is 0. 4 times 0 is 0, so that's going to be minus a 0, and then at the end is minus 8. And 0 minus 0 minus 8 is a -8. So once again, I put a 0 in for the variables. The answer was that number at the end. What's next? F of 1.
Could you show your pad? We just see your calculator.
Oh, you're just seeing my calculator? Ah, it does some
Yeah.
kind of, all right, let me see if I can refigure it.
I see the pad.
Are y'all seeing my pad now? Are y'all
Yes,
seeing
I
that
can see
pad
it
now?
just fine.
Okay. Yeah, I think sometimes what it is when I'm down here, my hands make it zoom or something. Woo, drives me crazy, y'all. All right, so this one is a 1 squared minus 4 times 1 minus 8. All right, y'all, 1 squared is 1 times 1 is 1. Minus 4 times 1 is 4, and then minus the 8. All right, so let's see. 1 minus 4 is -3. -3 minus 8 is a -11. And remember, you can do these on here. Let me click this screen. We can punch this exactly in here. 0 squared. Whoops, let me do the 1. 1 squared. 1 squared minus 4 times 1. Oh, minus 8. Punch all that in and you will get that -11. All right, let's put a 2 in. F of 2 is going to equal 2 squared minus 4 times 2 minus 8. All right, 2 squared is 2 times 2 is 4. Minus 4 times 2 is 8 minus the 8. All right, so let's see. 4 minus 8 is -4. -4 minus 8 is a -12. And y'all watch this. 2 to the second, arrowed over, minus 4 times 2 minus 8 will still give me -12. All right, let's go. Next is a 3. So f of 3 will equal 3 squared minus 4 times 3 minus 8. So 3 squared is 3 times 3, which is 9. Minus 4 times 3 is 12, minus the 8. All right, so let's see what we get. 9 minus 12 is -3. -3 minus 8 is -11. So now I'm starting to see a symmetry. It looks like that -12 is going to be my center point. So hopefully this 4 will give me what, a -8. So let's see. F of 4 will equal 4 squared minus 4 times 4 minus 8. All right, y'all, 4 times 4 is 16. Minus 4 times 4 is 16 minus 8. And y'all look at that. 16 minus 16 is 0. 0 minus 8 is a -8. So over here at 4, I would put -8. All right, so we're going to go to the math lab and graph this because it's one of the tricky ones. So we got to put in our answers real quick. So 0, I got what, a -8. At 1, I got a -11. At 2, I got a -12. And then I got what, a -11 here. And then I got a -8 for that one. So I got all my numbers in. So let's check this answer. And then graphing it. Because remember on this one, these are what we call quadratic equations when they got the x squared as the highest exponent. So you're going to go over here and click the parabola that says 3-point quadratic. And the first point has to be the center point, which is that 2, -12. So let me find 2 and -12. All right, so I'm at 2, -12. Click that one. Now, this one needs a point on both sides. So I'm going to have to pick 0 or 1 for the left side, and then the 3 or 4 for the x's on the other side. So I'm going to use 0, -8 on that left side. So there's 0, -8. And on the other side, I'm going to use the 4, -8. So here's 4 and then go down to -8. So I got my 3 points now. Then we're going to save this and check it. If you start at other points than the center, it's going to move your parabola to where that point is, and it's going to make it wrong, okay? All right, y'all, I'm going to actually pass this one and go to the next one because it's got a cube in it. So this has f of x equals x to the third plus 9. So let me get my x and y values. -2, -1, 0, 1, and 2. All right, switching screens back. All right, y'all see my paper?
Yes.
All right, so I'm going to find these 5 values and then we'll go graph them, okay? Because this tool's tricky too. So f of -2 will equal -2 to the third power plus 9. And y'all, negative numbers to odd exponents are going to stay negative no matter what. Now, if that was an even exponent like a 2 or 4, it would make this positive, okay? So -2 times -2 is 4, times -2 is a -8, plus 9. -8 plus 9 is 1. Then we're going to find f of -1, which will equal -1 to the third plus 9. -1 times -1 is 1, times -1 is a -1 plus 9. Remember, 9 minus 1 is 8. Larger number is positive, so that's going to stay positive. All right, f of 0 is 0 to the third plus 9. That's going to be 0 plus 9, which is 9. So once again, I put a 0 in for the variable. I got that number. What's next? F of 1. That's going to equal 1 to the third plus 9. So 1 times 1 times 1 is 1 plus 9, which will give us 10. And then finally, I got f of a positive 2. That's going to equal 2 to the third plus 9. All right, here we go. 2 times 2 is 4. 4 times 2 is 8. So that's 8 plus 9. Woo, that's what, 17. So at 2, I get 17. So let me let y'all write that a second, then we'll go graph this. And then after we graph it, we'll take a little break real quick. All right, y'all, so let's see, new screen. So on this one, we're going to have to put all 5 of these numbers in we just got. So I got a 1, 8, 9, 10, and then I got a 17. So what you would do is put your answers in and check them, and then hit OK. Now, since this has an exponent of 3, 3 means cubic. If you notice on here, 4-point cubic tool. That means I need to plot 4 of these points. And notice, since I had that 17 down here, this graph went up to 20s if you wanted to pick that point, okay? I'm just going to go in order. So let me go to -2, 1. Click that. -1, 8. Click that. 0, 9. Click that. Now watch this. When I do this last point, it's going to click them all around. There's 1 and 10. So that's 110 right there. When you put the fourth point, it gives it the curve you need. So it don't matter what points you use. I could have used that 217 and put it way up here, okay? Save that and check. All right, so I'm going to go to our main screen here. All right, so let's take about a 10-minute break. Let me see what this chat is real quick. Okay, people can see it then, okay. I'm gonna pause this. We're gonna take about a 10-minute break and then we'll come back and learn about the vertical line test and stuff like that. Trying to finish these lessons. So I'm gonna switch this back to the pad. All right, so next thing we're going to look at is another way to tell if something's a function by looking at a graph. So what we're going to learn about is what we call a vertical line test. So what this tells me that if it is possible for a vertical line to intersect a graph more than once, then the graph is not a function. Okay, so let me just sort of draw a little graph here to explain what we're talking about. So I have my X and my Y. So I'm just going to, we've been playing with them parabolas a lot, so I'm just going to draw a little parabola here. All right, then I thought I had them for you. So what they mean is we should be able to go left to right with a vertical line. So notice, this line only intersects my graph once everywhere I go. So since this line does not intersect my graph more than once, this is definitely what a function would be like. Okay, so watch this second graph. So say on this one I had a sort of parabola that was turned to the right. And I'm going through here and I'm running my vertical line. Well, notice now I got a place, it intersects it twice. So since my vertical line is intersecting my graph more than once, this would be a no. And that goes back to what we was doing earlier. All these X values can only have one Y value, not two different Y values, okay? Just like when you get paid, if you work 40 hours, you don't want to have a choice on what they're going to pay you. You want what you're supposed to get paid, okay? So what I'm going to do, I'll just put my little pictures up here. And we're going to look at these graphs and tell me if they're functions or not. So on this one, I would run my little vertical line left to right. And notice I'm only intersecting it once everywhere I go. And since I'm only intersecting that once anywhere on that graph, it is yes, definitely a function. So then you look at number 16 here. You're running your little vertical line left to right. Uh-oh, I'm intersecting this graph at the top and the bottom, quite a few places on it. So since I'm getting more than one Y value for these X's, this one would be a no. And y'all watch them, they're tricky. Here they got yes on top, no on bottom. This one they put no on top, yes on the bottom. So you sort of got to watch them with that, okay? All right, let me get the other pictures here. So any guesses if this is a function or not?
No, that's not a function.
No, because when you pass this thing, it's definitely what, hitting it twice in every place on it almost? So definitely a no. Well, what about this last one? It looks like a lot of jaggedy edges, don't it? But
Yeah,
guess
but it
what?
is a function.
If you go left to right, it's only intersecting at once everywhere on there, right? So since it's only intersecting the graph once everywhere, it's going to be a yes. And all you got to do is think about it. Do all my x's only have one y value they're going to? Okay. Alrighty, y'all. So that finishes up the 2.3. So now we're going to go into, that was 2.2. So now we'll look at 2.3. All right, so 2.3, and it's still doing pretty much the same thing. We're still doing functions. And then actually this one, we're going to do what we call finding the domains. And remember, domains are my x values, okay? So this first one, I'm going to put this picture up here because it's sort of hard to draw that. Can y'all see the picture pretty good? And notice it's got
Yes.
like four, they got 4 questions they want us to do. First, they want us to find f of -4. Now notice, they're not giving us an equation to use. So what they want to know is, what is the y value when your x is a -4? So I'm going to write that what they're actually asking for. So what is the y value when x equals -4? Because that's basically what they're asking us here. So what we need to do over here is come find the -4 on the x-axis and then go straight up to the point and see what that y value is. So I'm at -4, I go find my point, and it looks like that y value is a +2. So f of -4 would be 2. Now it says the domain. So on that one, we want to know what are the x values. Okay. Now we're not worried about the y values. We just want the x values. And I usually go left to right on these. So the first x I have is a -6. So you'd put -6, comma. This one has an x value of -5. This one had an x value of -4. This one had an x value of -3. So it looks like it's just following the graph left to right, right? -2. This one's at -1. And then finally, this one is on 0. So it's hard to put them all in that thing, but it'll give y'all more space on the math lab. But remember, all I want on my domain are the x values. So number C says any x values for which f of x equals 2. So what this question is asking us, what x value has a y value of 2? So sort of like number one, they gave me the x and wanted the y. On C, they gave me the y wanting the x. So we go find 2 up here on the y's, and we come and see which dots are on that 2 there, okay? So notice, this one has an x value of, what's that, -4. This one is also on 2, and it has an x value of -2. Okay, so both of these x's had a value of 2 on the y-axis, okay? Then it says, what is the range? The range is the y values. So what are the y values? And usually on those, I'll start from the smallest and go up. So the smallest y value is this little peak right here. And if you go across, it's got a y value of 1. These points have a y value of 2. And notice, I don't have to write the 2 but once. Although there was 2 points, I just need to write the 2 once. These 2 points have a y value of 3. And y'all, finally, these 2 points had a y value of 4. So the trick on this one is just figuring out what they were asking for on it, okay? And that was it. Just go through, put your numbers down and be done on that. And they don't have to graph it because they done had it graphed for us.
Wait, I have a question.
Did y'all have a question?
Oh, yes. Could you go over C again?
So C, up here they said any x values for which f of x equals 2. So remember, when you're in this form of f of x equals a number, this here is where you find the x values. And then this is actually what you're going to get for your y values, okay? So they're saying, hey, your f of x equals 2. So we want to know what x's can I find that have a y value that equaled 2. So what I went up here, I seen on my y-axis where 2 was. And remember, any line, any point that's on that horizontal line would have a y value of 2. So here we was at what, negative 2, 2. So that meant negative 2 was one of my numbers. And then this point was at negative 4, 2. So that was negative 4 for that x. So you're just looking for any x's that gave you the y value of a 2 on that one, okay? That make more sense?
Yes, thank you.
Okay. All righty, so I'm gonna play with the domains a little bit because those ones we had single points we could plot, right? But what if I had a graph? So here would be my x and my y. So say I had a graph that went forever. So we need to learn new symbolism for these because there's no stopping point. This graph is going and going and going. And as a graph grows to the right, we say it's headed towards what we call positive infinity. And these graphs pointing to the left are coming in from what we call negative infinity. And y'all, that does the same on your ranges. Down here would be headed towards negative infinity, and up toward them positive numbers would be headed towards positive infinity. So when your graph covers all the points and has no stopping point, we're going to use what we call interval notation. And we're going to use these infinities, okay? So to represent all numbers for a domain, we would go from what we call negative infinity to a positive infinity. This represents all real numbers, okay? So I'm going to pull my sheet back for you. So notice on this, and the first thing they want to find is f of 3. So that means, what is the y value when x is 3? All right, so I'll write that here. What is y value when x equals 3? Well, let's go find 3 on the x-axis. Here's 3. Go straight up, and it looks like that's intersecting at 3 on the y-axis. So f of 3 would be 3. All right, let's see what this one wants. What is the domain? Now, here we would use numbers, but y'all, there's not an ending number because these arrows are going on forever and ever. So it's like it's heading from negative infinity to a positive infinity. But notice they don't have that answer choice. But remember, I also said down here that this could also represent what? All real numbers. And if you notice on their answer, E, it says the domain is all real numbers. So you would click E and be done. Now, this next one is sort of like you asked me about on that last question. For what x values is f of x equals 1? So come up here, find 1 on the y-axis, and go across and tell me what these two x values are. So this one intersects the line at 5, so it would be a 5. This one intersects the line at 7, so at 5 and 7. So where's 5? We got an x value of 1. 7, we got a y value of 1, okay? So that's what that part was wanting to know. What x values had a y value? So what x values gave a y value of 1? So what is the range? So the range is the y values. And notice my smallest y value is right here at 0. I don't have no negative y values. So it cannot be all real numbers because we don't have the negative numbers. So our smallest y value is 0, and then it heads towards that positive infinity. So that means that the y's have to be greater than or equal to 0. So you would pick D on that one and put in your 0. Now you cannot pick A because it don't have the equal bar on it, okay? And this thing definitely does equal 0 at that 6, okay? And that was it on that one, right? So I'm gonna pull this and go back to my pad. All right, so in this next section, we're going to do domain in what we call set builder notation. Now, y'all, later on in life, we'll get back into this interval stuff. I think that happens in chapter 5 or 6, okay? So, set builder notation, they use these fancy parentheses. They put the variable in there, so that's going to name the variable. Then you'll see a bar. That bar means such that. So if you ever had a computer and you wondered what that bar means, it means such that. And then over here we put the conditions. The conditions are like x is greater than 5, x is equal to 5, x cannot be 5, and so on, okay? Now, on a domain, there's only two things we're worried about on a domain. First thing we're worried about are fractions. Because on a fraction, the bottom of that fraction cannot equal a certain number. And that number is 0. So let me show you on this calculator. If I try to divide any number by 0, y'all, I'm going to get an error because I tried to divide by 0 and I cannot do that. So if we got fractions and there's a variable in the bottom, we got to worry about it. So on fractions, if a variable is on bottom, we must remove any numbers that make the bottom equal 0. Okay, so the bottom of that fraction cannot equal 0. Now, the second thing you're worried about, we're not going to see in this section, but we will later on, is a radical. Because on a radical, this number cannot be less than 0. So let me show you. If you had a radical, second, where's my radical? X squared, and you put in a negative number, you can't do it. It gives you another error because that gives you what we call imaginary numbers. So this A would have to be greater than or equal to 0 in a radical, okay? So that's where y'all was messing with them numbers like 2i and 3i and all that fun stuff, okay? Now, if it's not a fraction or a radical, it will work for all real numbers, okay? So these examples, and let's see, that's about the last of them. We'll go through about 4 or 5 of these examples, and then that'll be it really for today. So what we're going to do is find the domain of each function. And these will start about number 3 for y'all, so I'll write these in the order y'all are going to get them. So number 3, they got f of x equals 13 divided by x plus 10. So this is one of the 2 things I was worried about. I was worried about fractions, and that's what they gave me. So to solve this, we know that that x plus 10 cannot equal 0. So set the bottom to 0. Now you're going to solve this. Then solve for x. Well, y'all, one move on this, I'm going to subtract 10 from both sides so that it tells me x cannot equal a negative 10. Because if I put a negative 10 in for x, I get a 0. 13 divided by 0 makes that undefined. So in set builder notation, now I think they give you this part of it. All you got to do is put in which answer we got. And ours told us what? X cannot equal negative 10. So basically, put your answers into them blocks and be done. And y'all, here you go. So look what they're saying. So x is a real number not equal to 0. X is a real number. X is a real number and cannot equal negative 10 or 0. X is a real number and x cannot equal negative 10. So on that, and we're definitely going to go with D on that, okay? So their answers will sort of be like the answers you're getting on your equations. All right, how about this one? P of X equals 2X minus 9. Well, guess what? There's no fractions here. And we know there's not going to be any radicals yet because we ain't even messed with radicals. So since there's no fractions, this one works for all real numbers. So you would have X such that X is a real number. So let me show you what they did to that. Same thing, right? X such it's a real number. Because there's no numbers we got to exclude. Because y'all, if you put a 0 in, 2 times 0 is 0. 0 minus 9 is negative 9. That don't make it undefined. You put a 9 in, that gives you 18 minus 9. That's not undefined. Only way you're going to get undefined is if you got fractions. And since we didn't have a fraction, that worked for all real numbers. All right, 5 is P of X equals X squared plus 1. Y'all, guess what? There's still no fractions. So since I have no fractions, it's going to be the same thing, right? X such that X is a real number. Six has G of X equals 9 divided by 9 minus 5X. So guess what? You do have a fraction, so we're going to take the bottom and set it not equal to 0. So 9 minus 5x cannot equal 0. We're going to solve it for that x and see what we get. So y'all, to solve this, I'd probably subtract 9 first. That'll give me negative 5x is not equal to a negative 9. And then divide both sides by that negative 5. So that x cannot equal, now notice these negatives cancel, so this becomes a positive 9 over 5. So our answer would be x such that x is a real number and x is not equal to a 9/5. So y'all, these aren't bad. You're going to have 2 or 3 where you actually got to set that bottom not equal to the 0. And then you'll have some that are just linear looking equations. And those are going to work for all real numbers. Oh, look at this one. P of x equals absolute value of x minus 8. All right, so once again, I have no fractions. So there's nothing on bottom because there's not a fraction there. So this works for all real numbers, x such that x is a real number. Because y'all, any number on that number line I can put in here and this will work, okay? All right, then finally we end up with a P of x equals x to the third minus 6. All right, so finally, guess what? This one has no fractions. So once again, no matter what number I put in for the x, I can cube it and subtract 6. So this will work for x such that x is a real number. And that's why we went to interval notation later in life, because that's a lot of stuff to write when I could just put negative infinity to infinity and be done on those, okay? All righty, so that was 2, 2, and 2, 3. So I'm going to stop my share. All right, so do y'all have any questions?
Can you go back to the notepad, please?
Uh-huh. On this one right here?
Number 8.
Yeah. And then y'all should be sort of set up similar to my questions as I'm going through them. They might change them up. Y'all might have like an x3 minus 8, x3 minus 4 or something. But you still want to do the same thing. You know, if it's fractions, you're worried about it. If not, move on, okay?
Could you work one that has a square root?
Say again now.
Like, could you work one that has a square root?
Oh, now we don't have one yet, but let me show you what would happen if you did. So say I had f of x equaled the square root of, say, x plus 4. Now remember, we cannot take square roots of negative numbers, okay? So what that means on these problems, you would take the x plus 4, and it would have to be greater than or equal to 0. Because see, over here, my calculator can do a square root of a 0 and get 0. But as soon as I try to go in and take a square root of a -1, I'm going to get a error. So we got to make sure that whatever's under here is equal to or greater than 0. So let's see, to solve this, I would what? Subtract 4 from both sides. So that x has to be greater than or equal to a -4. Now, -4 plus 4 is 0. I can do the absolute value 0. Any number greater than -4 would be like -3, -2, -1, 0, and so on. Those will all keep that positive. But as soon as you went to like a -5, which would be less, -5 plus 4 would make that -1, and then that would make it imaginary. So on this one, we would have what? X such that x is real and x is greater than or equal to a -4. I think this will hit us on the second test. Toward the end of it, you'll sort of get some of these radicals in here. And that's the main thing. I'll tell you the biggest thing on a radical one. Let me show y'all one of them real quick. What if I had this? What if it was 6 minus x? This is where I get some people solving this one, because we know what? 6 minus x has to be greater than or equal to 0. So solving this, I would probably subtract 6 from both sides first. And I would get a -x is greater than or equal to a -6. So now to make that x positive, I got to divide both sides by the -1. So I get a positive x. What would I do next? Remember, there's one
Won't you
thing.
flip the
Yeah, I gotta
sign?
flip it, right? I gotta make that a less than or equal. So anytime you divide or multiply by negatives, you gotta flip the little inequality around. And then -6 divided by -1 would make that a 6. So 6 minus 6 would give me 0. I could do that. But any numbers bigger than 6, like a 7, 6 minus 7 would make that -1, which I can't do. So my domain would be x such that x is real and x would be have to less than or equal to a +6. So really, that's the thing where I get most people is that y'all forget to sometimes flip it around when you're dividing by the negatives. So it makes your answers over here a little bit off. I don't think those are too bad though, do y'all? All right, y'all good with that?
Yeah.
All right, I'm trying to stop my share. All right. All right, so I'll stop recording this and let y'all have a 10-minute break. And then if any of y'all need support work with me, we'll do our lab. And what I'll do is I'll